Hello and welcome to this lecture on reliability and maintainability. Let's understand what is reliability means, maintainability means and availability means. Reliability is the probability that machinery, equipment, system can perform continuously without failure for a specified time interval when operating under the stated conditions. Increased reliability implies less failure and consequently less downtime and loss of production. It means that a given machine or given tool or given equipment performs its specified function for a given time frame without failure. Maintainability is the characteristics of a design, installation, and operation, usually expressed as the probability that a machine can be trained in or restored to a specified operable condition within a specified interval of time when maintenance is performed in accordance with prescribed procedures. That means it is a probability that the maintenance occur in time, that's all. Availability is the probability that an atom will be able to function, not fail or undergone repair when called upon to do so. Availability means when you want a certain tool or equipment to perform a certain operation. Let's take an example of tool grinding. Supposing one would want to resharpen the tool, a grinder should be available, it should be in working condition, that is called as availability. This measure takes into the account an atom's reliability, how quickly it fails, and its maintainability, how quickly it can be repaired. So availability is the function of reliability and maintainability. Now let's understand what are the types of failure. There are functional failures, failures that occurs at the start of production life due to manufacturing or material defects. There are reliability failures, failure after some period of use. This relates to the bathtub curve that we will explain in a short span of time. Types of reliability: inherent reliability predicted by product design, achieved reliability observed during use based on observed failure data. As I have already explained, the bathtub curve is used for a reliability calculation. So on a y-axis it is increased failure rate, while on the x-axis it is a time frame. So when the product is new, there is infant mortality, decreasing failure rate goes on as maturity of the product increases. During the initial phase of a product development, more failure happens. Once the growth happens or a product becomes stabilized, a production becomes continuous, then decreasing failure rate happens. There is a time frame where the normal life or useful life of the product exists. Low or constant failure rates are observed in that particular phase. And there is end of life wear out phase wherein increasing failure rate happens. The first period is characterized by decreasing failure rate. It is what occurs during the early life of a population of units. The weaker units die off, leaving a population that is more rigorous. This first period is also called infant mortality period. The reason for early failures are due to design faults, poor quality components, manufacturing faults, installation errors, and operator and maintenance errors. The next period is flat portion of the graph. It is called as normal life. Failure occurs more in a random sequence during this time. It is difficult to predict which failure mode will manifest, but the rate of failures are predictable. The third period begins at the point where the slope begins to increase and extend to the end of graph. This is what happens when the unit becomes old and become to fail at an increasing rate. So as per bathtub, any new product which is installed, it has a more probability of failure in the initial phase itself when it is accommodating into the machine. Then there is a useful life wherein it doesn't fail, and at the end when the design time frame or a design performance of the equipment is taken out, at the end there is a third period begins and it becomes old and begin to fail at increasing rate. Now how do we measure reliability? There are certain ways by which you can measure reliability. Failure rate, number of failures per time. Alternative measures are mean time to failure, mean time between failures. Reliability is the probability of operating to an agreed level of performance. Unreliability, that is FT, the probability of failing to operate at an agreed level of performance. Reliability and unreliability becomes one. It is simply like a probability. Reliability function for service life. Probability density function for failure time is the exponential. It is assumed to be exponential form wherein t is greater than 0. Probability of failure from 0 to 2 is exponential function. Failure rate is lambda. Reliability function becomes 1 minus ft, that is e to the power minus lambda t. Viable analysis. Viable analysis can be used as a method of determining where a population of models is on the bathtub curve or not. The viable distribution is a 3-parameter distribution as explained in this formula. There is a beta, there is a eta, and there is t. More discussion is provided in the video 2 for the same topic. So viable distribution, numericals on bathtub curves, determining reliability function, finding out unreliability, everything is discussed in video 2 for the same topic. Now mean time between failures is the basis function of system's reliability. It is typically represented in units of hours. Higher the MTBF number is, higher the reliability of the product. It is calculated as reliability is equals to e raised to power minus t upon MTBF, that is mean time between failures. Now MTTR, that is mean time to repair or recover, is expected time to recover a system from failure. This may include the time it takes to diagnose the problem, the time it takes to get repair technician outside, and the time it takes physically repair the system. Similar to MTBF, MTTR represent in units of hours. As equation shows, MTTR impacts availability and not reliability. The longer the MTTR, the worse of the system is. So availability is equals to MTBF divided by MTBF plus MTTR, that is mean time to repair. Numericals on these equations would be explained in video 2 of the same topic. Let's understand maintainability and availability in detail. Repairable systems receive maintenance actions that restore the equipment to a functioning state when they fail. That is repairable system. You can repair the system and get the performance back which was there before the failure happened. The maintenance time of a equipment must now be taken into the consideration in assessing the behavior of the system, since the time of operation is no longer continuous. When considering repairable system, both the reliability and maintainability must be taken into account. For example, a system that fails often but is easy to repair may have same overall accessibility as more reliable system that is difficult to repair or maintain. Say for an example, you have a normal lathe and you have a CNC lathe. When CNC lathe fails, it takes 8 to 10 days for repair, for example. While if the normal lathe fails, it takes hardly 1 day to repair. So accessibility or availability of normal lathe is more as compared with CNC lathe, because normal lathe gets repaired very easily and is available immediately. Availability takes into account reliability and maintainability of the system. A normal lathe maintainability is very high, although reliability is low. So overall constant availability becomes high. Maintenance for repairable systems. Maintenance is defined as any action that restores the fail unit to the operational condition or retains non-fail units in an operational condition. For repairable system, maintenance plays a vital role in the life of system. It affects its reliability, its availability, its downtime, its cost of operation, etc. Maintenance actions can be divided into two types: corrective maintenance and preventive maintenance. Now corrective maintenance, as the name implies, the actions taken so that failed system is restored to the operational status. This usually involves replacing or repairing a component or subsystem that is responsible for the failure of the overall system. Any component is failed inside the machine is replaced and corrective action is taken so that maintenance is again on the road. Like for example, if your vehicle tire is punctured, you replace or you do a maintenance of that particular tube of the tire, and again a vehicle is on the road ready to use. That is called as corrective maintenance. Such maintenance is performed at unpredictable intervals, since a component's failure time is not known because you don't know when the puncture of a tire will happen. The objective of corrective maintenance is to restore the system to satisfactory operation within the shortest possible time. Now, what are the components of the maintenance? Corrective maintenance. Diagnosis of a problem. The maintenance technician must take a time to locate the failed part or otherwise satisfactorily assess the cause of a system failure. Like the tube of a vehicle is failed. So maintenance technician takes out that tube, fill the air in, put it into the water, see the bubble coming and locate where the failure has happened. Repair and replacement of the faulty components. Once the cause of a system failure has determined, action must be taken to address the cause, usually by replacing or repairing the component that caused the system to fail. Like he locates the puncture patch, he puts another patch of a tire or a tube on that, applies heat, makes sure that everything is okay. Again, verification of the repair action. Once the component in the question has been repaired or replaced, the maintenance technician must verify that the system is again successfully operating. He again fills the air into the tube, put it into the water tub and see whether the puncture is properly filled or not. That is verification of repair action. Now what is preventive maintenance? Preventive maintenance is the practice of replacing components or subsystems before they fail in order to promote continuous system operation. The schedule for preventive maintenance is based on observation of past system behavior and a knowledge of which components are vital to continuous system operation. In many circumstances, it is financially more sensible to replace parts or components that have not failed at the predetermined intervals rather than wait for a system failure that may result in a costly disruption in the operation. Like for example, every 2 months or after certain kilometers, a vehicle is advised to go through overhaul. We call it as overhaul of a vehicle. In that overhaul, a lubrication change, oil change in the component happen. All the components are tested properly whether they are functioning or not. Like carburetor is checked, like air in the tubes are properly checked, all the valves are functioning or not is checked, spark plug is checked. So these are preventive maintenance, and if they are near to the failures, their replacement is taken place so that it is avoided that the system is continuous to give its performance. Now what is downtime and downtime distribution? Each time a preventive or corrective maintenance action is performed for repairable system, there is an associated time to complete such action. This is known as downtime. It is defined as length of time of a component, subsystem or a system is not operational. Downtime is divided into two categories, waiting downtime and active downtime. Now, for example, when the vehicle is punctured, it takes some time to go to the person who will repair it. He takes time to repair a system and put it back into the action, and again vehicle is ready to run on the road. Similarly, in case of preventive maintenance also, your overall of the vehicle is scheduled. So in the morning you give the vehicle to the facility, and by the evening you collect the vehicle from the facility. So it takes time. The vehicle is not running during that particular time. It is called as downtime. It can be divided into two categories like waiting downtime and active downtime. Waiting downtime, as the name suggests, this is time during which the equipment is inoperable but not yet undergone repair. This could be due to the time it takes for the replacement of parts to be shipped, administrative processing time, etc. Like the vehicle is punctured. It is not necessary that a person who will carry out or who will take care of the puncture is easily available. So it takes time to move vehicle from the place where the puncture has happened to the place where a person who will carry out the puncture is sitting. Then doing administrative type, giving him money and fixing up the things, checking whether it is properly done or not. These all called as waiting time. Like for overall maintenance also, you have to give a vehicle, you have to book overall maintenance time, you have to drive that vehicle to the facility, you have to drive back vehicle from the facility after the maintenance is done to the home. It is called as waiting downtime. Now there is active downtime. This is a time during which the equipment is inoperable and actually undergone repair. In other words, the actual downtime is the time it takes to repair or perform repair or replacement. The length of the active downtime is generally dependent on the human factor as well as the design of the equipment. For example, the ease of accessibility of the components in the system has direct effect on the active downtime. Availability for repairable systems. Availability is the performance criteria for repairable system that accounts for both the reliability and the maintainability aspects of the system. It is defined as the probability that the system is operating properly when it is required to use. This is availability is the probability that the system is not failed or undergone a repair action when it is needed to be used. For example, if the lamp has 99.9% availability, there will be one time out of 1000 times someone needs to use the lamp but it is inoperational because maybe switch is broken or it is waiting for the replacement of the light bulb or electricity is not there, etc. Now availability is the measure of readiness of the system. Let's compare what is a difference between reliability, maintenance and availability. If the reliability is constant, maintenance is increases, then availability is decreases because more and more time it is required to maintain and thus availability is reduces. If the reliability is constant, maintenance decreases, then the availability increases. Of course, if the reliability increases, maintenance constant, availability is more because the product is more reliable. It is able to function. Its reliability or performance is constant. It gives a performance when it is needed. So availability is more. If the reliability decreases, maintenance constant, availability decreases. Like for example, normal lathe. Reliability is more, although maintenance is constant. Say for example, if you have two lathe machines, like normal lathe machine and CNC and say numerical control lathe machine. If the maintenance is constant in both cases, if the reliability of the normal lathe is less, its availability is also less. More discussion and numerical examples on these topics are provided into video 2 for the same topic. Let's understand preventive maintenance for repairable system. Preventive maintenance is a schedule of a planned maintenance action aimed at the prevention of the breakdown and defects. Like when we give our vehicle after 2 months or after certain kilometers of run to overall, it is called as preventive maintenance. The primary goal of preventive maintenance is to prevent the failure of our equipment before it actually occurs. It is designed to preserve and enhance equipment reliability by replacing worn components before they actually fail. Preventive maintenance activities include equipment checks, partial or complete overhauls at specified period, oil changes, lubrications and so on, as I've already explained. In addition, workers can record equipment deterioration so that they know to replace or repair worn out part before they cause system failure. Like when you go to overhaul station, then a person who has done overhaul for your vehicle tells you that this particular clutch plate has been worn out, you have to replace it, it is required to replace, or gear has worn out, or oil is required to be changed. These type of things are getting recorded and also comes into notice of a person who is using that particular equipment. Now, what is the value of preventing maintenance? It has long-term benefits. It improves system's reliability. The system or a vehicle will run when I am required to use it. Decrease cost of replacement. If I know that the particular part is gonna worn out, it is required to be replaced, I'll replace it there and there itself, and thus reduce the cost of replacement. If it is not replaced in time, it may be possible that it causes the failure of other parts also. Decrease system downtime. Better space inventory management, as it is very clearly understood. With preventive maintenance, for example, cost of lost production time for unscheduled equipment breakdown will be incurred. Also, preventive maintenance will result in saving due to increase of effective system service life. Total productive maintenance (TPM) brings maintenance into focus as a necessary and vitally important part of the business. Now, what are the objectives of TPM? Avoid wastage in a quickly changing economic environment, producing goods without reducing product quality, reduce costs, produce a low batch quantity at the earliest possible time. Goods sent to the customer must be non-defective. It ensures that goods sent to the customer are non-defective. Now we have already discussed TQM. Then what is the difference between TQM and TPM? So the TPM program closely resembles the popular total quality management, that is TQM program. Many of the tools such as employee empowerment, benchmarking, documentation, etc. are similarities between these two. Some more similarities are total commitment to the program by upper level management is required in both programs. Employees must be empowered to initiate corrective actions. A long range outlook must be accepted, as TPM may take a year or more to implement, and it is an ongoing process. Changes in the employee mindset towards their job responsibilities must take place as well. Now we have discussed what are the similarities between them. What is the difference between TQM and TPM? Category: objective. TPM is a quality ensured thing, while TPM is an equipment ensured thing. It is related to equipment, while TQM is a quality of a product. Category: means of attaining goal. TQM is systematize the management. It is software oriented. TPM is employee participation and it is hardware oriented. category target, TQM is quality for PPM, while TPM is elimination of losses and wastage. What are the types of maintenance? Like we have categorized the maintenance into preventive maintenance and actual maintenance. So types of maintenance are breakdown maintenance and preventive maintenance. It means that the people wait until the equipment fails and repair it. Such a thing could be used when the equipment failure does not significantly affect the operation or production or generate any significant loss other than repair cost. This type of maintenance normally is not taken into a place or it's not being used in an industry. Preventive maintenance, it is a daily maintenance, cleaning, inspection, oiling and retightening, designed to retain the healthy condition of equipment and prevent failure through the prevention of deterioration. Periodic inspection or equipment condition diagnosis to measure deterioration. Now, preventive maintenance can be of two categories. Periodic maintenance, that time-based maintenance. Time-based maintenance consists of periodically inspecting, servicing and cleaning the equipment and replacing parts to prevent sudden failure and process problem. Predictive maintenance, like periodic maintenance and predictive maintenance are a part of preventive maintenance. This is a method in which service life of important part is predicted based on an inspection and diagnosis in order to use the parts to the limit of their service life. Compared to periodic maintenance, predictive maintenance is a condition based on maintenance. Now there is corrective maintenance. It improves equipment and its component so that preventive maintenance can be carried out reliably. Equipment with design weakness must be redesigned to improve reliability or improving maintainability. Maintenance prevention. It indicates the design of new equipment. Weakness of current machines are sufficiently studied. On-site information leading to failure prevention, easier maintenance and prevents of defect, safety and ease of manufacturing. These are incorporated before the commissioning of new equipment. Now let's understand TPM process in more detail. What are the motives of TPM? Adoption of life cycle approach for improving the overall performance of production equipment. Improving productivity by highly motivated workers, which is achieved by job enlargement. The use of voluntarily small group activities for identifying the cause of failure, possible plant and equipment modification. Uniqueness of TPM. The major difference between TPM and other concepts is that the operators are also made to involved in the maintenance process. The concept 1 is production operator, operate, you, maintenance operator, fix is not followed. TPM objectives: achieve zero defect, zero breakdown, zero accidents in all functional areas of organization. It involved people in all level of organization from different teams to reduce defect and self-maintenance. What are the direct benefits of TPM? Increase productivity and OPE, that is overall plant efficiency, by 1.5 to 2 times. Rectify customer complaints. Then reduce the manufacturing cost up to by 30%. Satisfy customer needs by 100%, delivering the right quantity at the time and required quality. Reduce accidents. Follow pollution control measures. Now what are the indirect benefits of TPM? Higher confidence level among the employees. Keep the workplace clean, neat and attractive. Favorable change in attitude of operator. Achieve goals by working as a team. Horizontal development of a new concept in all areas of the organization. Share knowledge and experience. These are indirect benefits of TPM. Now what are the pillars of TPM? As you can see, there is one pillar and 6-7 pillars above which the TPM is mounted. Pillar 1 is 5S pillar. TPM starts with 5S. Problems cannot be clearly seen when the workplace is unorganized. Cleaning and organizing workplace helps the team to uncover the problem. Making problem visible is the first step to improvement. These 5 A's are sort, systematize, sweep, that is clean, standardize, and self-discipline. I repeat, sort, systematize, sweep, standardize, self-discipline. Pillar 2 is autonomous maintenance. This pillar is geared towards developing operator to be able to take care of small maintenance tasks, thus freeing up the skilled maintenance people to spend time on more value-added activity and technical repairs. The operators are responsible for upkeeping of their equipment to prevent it from deteriorating, like small oiling, greasing, cleaning, removing chips. These particular activities is required to be done by the operator who is using that particular machine, is the meaning of this pillar 2. The policy is uninterrupted operation of the equipments, flexible operation to operate and maintain other equipments, eliminating the defect as source through active employee participation. The employee is actively participated in the maintenance activity itself. Now pillar 3, Kaizen. You must have heard of this term Kaizen. Kaizen means change and Zen means good. So good change or for better. Basically Kaizen is small improvements but carried out on a continuous basis and involve all people in the organization. Kaizen is opposite to big spectacular innovation. Kaizen requires no or little investment. These activities are not limited to production areas and can be implemented in administrative areas as well. Now what are the policies of Kaizen? Practice concept of zero losses in every sphere of activity. Relentless pursuit to achieve cost reduction targets in all resources. Relentless pursuit to improve overall all plant equipment effectiveness. Extensive use of PM analysis as a tool for eliminating losses. It also aims to achieve 30% manufacturing cost reduction. Pillar 4 is plant maintenance. It is aimed to have trouble-free machines and equipment producing defects-free products for total customer satisfaction. This breaks maintenance down into 4 families, group which I have already defined earlier: preventive maintenance, breakdown maintenance, corrective maintenance, and maintenance prevention. With plant maintenance, we evolved our efforts from a reactive to proactive method and use trained maintenance staff to help train the operator to better maintain their equipment. This is plant maintenance. Now what are the policies? Achieve a sustained availability of machine, optimum maintenance cost, reduce spares inventory, improve reliability and maintainability of machines. What are the targets? Zero equipment failure and breakdown, improve reliability and maintainability by 50%, reduce maintenance costs by 20%, ensure availability of spares all the time. Now pillar 5, quality maintenance. It is aimed towards customer delight through highest quality through defect-free manufacturing. Focus is on elimination of non-conformance in a systematic manner, much like focus improvement. We gain understanding of what parts of the equipment affects the product quality and begin to eliminate current quality concern. Then move to the potential quality concern. Transition is from reactive to proactive, quality control to quality assurance. QM activity is to set equipment conditions that preclude quality defects based on basis concept of maintaining performance perfect equipment to maintain perfectly quality product. Like if the product is need to be perfect or quality ensured, the equipment should be in very good condition. And how do you ensure that condition of the equipment is good? Is by quality maintenance, by involving a personnel who is using that equipment. He is taking care of proper oiling, greasing, and preventing maintenance is carried out, or scheduled maintenance is carried out of the equipment, so that the product which is being manufactured by using that particular machine would be quality product in itself. What are the policies? Defect-free conditions and control of equipments, QM activities to support quality assurance, focus on prevention of defects at source, focus on POCA-YOCA, that is foolproof system, inline detection and segregation of defects, effective implementation of operator quality assurance. The targets are achieve and sustain customer complaints at 0, reduce in-process defects by 50%, reduce cost of quality by 50%. Now what is the last pillar? Training. It is aimed to have multi-skill, revitalized employees whose morale is high and who is eager to come to work and perform all required functions effectively and independently. Education is given to the operator to upgrade their skills. It is not sufficient to know how, but they should also know why. By experience they gain know how to overcome a problem, what to be done. This they do without knowing the root cause of the problem and why they are doing so. Hence it becomes necessary to train them on know why. Like if supposing equipment has failed, then why it has failed, what exactly went wrong is being communicated to the person who would be using that particular equipment or who is using that particular equipment while the failure has happened. So the similar mistake or similar problem will not occur in future, and an employee who is using that equipment can give a feedback in time to a maintenance team that if something is wrong in the equipment itself. The employees should be trained to achieve the 4 phases of skills. The goal is to create factory full of experts. Thank you for listening this lecture. Thank you.